Okay, guys, so on this lesson, we're gonna have a look of total internal reflection, okay? So hopefully you guys have copied down the notes. So for this video, I'm just gonna quickly show you the experiment. Again, we're gonna be using this virtual experiment, which is using the PHET website. You've already seen how I used it in the last video. So you're gonna go to the simulation that's on Google Classroom, then you can have a look. Okay, so again, I'm gonna click intro. So I'm gonna have a light ray and see refraction, how light gets bent closer to the normal line. Okay, you can see all these situations light closer to the normal line. Okay, so nothing particular over here. So just what we learned before. Okay, so now we want to change the material going from a dense medium, let's say glass, into a light medium, let's say air. Okay, so let's see. The light ray is going to bend away from the line, so the refraction angle needs to be bigger than the incident angle, okay? All right, so if I'm keep going, and the angle is going to get bigger and bigger and bigger. I mean, it can't just keep going bigger because eventually it's going to reach 90 degree over here, right? And then what's going to happen? So let's have a look. Well, it's going to keep going, and then once it passes 90 degree, then you can see light ray actually does not refract anymore. It does not come into this new medium anymore. It actually just get reflected. Okay, and then this type of reflection, we give it a name, we call it total internal reflection because it has been reflected into this thing over here. It does not need a mirror over here. It can just reflect into itself. So that's why we call it total internal reflection. Okay, let's try it again. You can see how this is increasing, and then bam, now reflection start to happen, total internal reflection, okay? All right, and again, this only happens when light going from a dense medium to a light medium, okay? All right, now over here we have a very important thing, which is when does it first start to happen? When it first start to happen, that's when this refraction angle is going to be 90 degree. If it's exactly 90 degree, and then you can see it will disappear. And in this incident angle, we give it a special name. When the refraction angle is 90 degree over here, this angle we call it a critical angle. Okay, so critical angle is when total internal reflection starts to happen. So if it's bigger than critical angle, if the incident angle is bigger than the critical angle we had, then total internal reflection is going to happen. If it's smaller than the critical angle, and then it's going to be refraction. Okay, all right, let's measure how big is the critical angle here. So say I put the thing here. I'm gonna move it. Okay, critical angle is about 41 degree. Okay, so any angle that's bigger than 41 degree, then it's gonna be total internal reflection. It's smaller than 41 degree, then it's gonna be refraction. Okay, so what is this critical angle dependent on? So it doesn't matter how big my incident angle is. Critical angle is already decided. It's actually already 41 degree. So you can guess it's probably dependent on the medium, right? If I change the medium, so now I can see I've changed the glass to a very high density object over here. Let's see, now the critical angle has become about 39 degree over here. Okay, and then if I make it to become water, let's see how big is the critical angle. Okay, I can test it. Now critical angle is about 48 degree, 49 degree. Okay, so you can see critical angle is dependent on the medium and which it can be calculated by using the refractive index. Okay, so we're gonna see how do we calculate it, how do we in the next video. So, but first we're gonna see, well, there is a critical angle. When critical angle happens, the refraction becomes 90 degree, and then once we pass that, that's total internal reflection. And then once we're below that, that's refraction. Okay.